I'd like to introduce Michael Lucas. Michael Lucas is the author of over 50 books now, not 30. He is an accomplished writer of such topics as SSH mastery, ZFS mastery. Basically, if you have any technical topics that you would like to learn more about, I'm pretty sure that Michael Lucas has either written about it or has consciously decided that he no longer wants to write about that. His latest book that will be coming out soon, in the foreseeable future, assuming that all goes well and that the earth is not swallowed up and its madness, is the book about running your own mail server, which hopefully we'll have a talk about that upcoming. And with that, I would like to introduce Michael Lucas. And I will allow you to share your screen there we go.
Let's see, share screen. Okay.
There we go.
Folks see my opening slide?
I can.
Yes.
We're good.
Okay, excellent. Hi, everyone. Thanks for having me. This is my talk on OpenBSD file systems. And come on, why are you not advancing? There we go. As you can probably guess, it's based on a book. Even if you don't care at all about OpenBSD, I would tell you that the cover art is magnificent and you should own it. Wait a minute, this is the wrong slide deck. This is the 4-hour tutorial, not the 1-hour talk.
Talk faster.
Hold on a second.
We're gonna be here for a while.
Right.
Still like the
I have
cover.
not had dinner yet. You are not getting the full thing.
Well, we're definitely getting what we paid for.
Oh, yes. Yes, you're getting every bit that you paid for. Okay, back to Zoom, share screen. Back to Zoom, share screen.
Yay.
Okay, let's try this again. Hi, thanks for having me. This is my brief talk on OpenBSD file systems. And who am I and why am I here? Well, I've been Unixing since the late 80s. Had I known this would be such a part of my life, I would have noted the date I got my first account, but oh well. So, OpenBSD. Most of you have probably heard the word before, even if you don't know what it is. So, it's a BSD 4.4 derivative, aka real Unix. And it says that it focuses on portability, standardization, correctness, proactive security, and integrated cryptography. And that all sounds like good stuff. But you don't hear much about how it manages file systems. What does it do for data storage? File systems really are the soul and center of systems administration. You can set up your computer perfectly with all the programs you want, but if you mess up the file systems, you're done. And you don't hear much about it because it has very straightforward philosophy. This is something I hate quoting from my own books, except when my books are quoting me. But this is something I parodied Hitchhiker's Guide to the Galaxy for this book. And this quote kind of sums up how OpenBSD thinks about storage. that many users assume their advanced file system is better than UFS because it has so many features like snapshots, checksums, compression, caching algorithms, and so on, while all UFS has ever done is muck about putting data on disk. But conversely, UFS users believe their file system is better for exactly the same reasons. File systems like ButterFS and ZFS have all this cool stuff in them, but they're kind of like another operating system. And they have added complexity. Every feature demands complexity. And OpenBSD says, no, be simple, just put the data on the disk, and the operating system has other tools to do the checksumming and whatnot. But if we're talking about disks, we kind of have to look back in history a bit. What you see there in that picture is an IBM Model 350. And it had all sorts of things you had to look at, like the number of cylinders, heads, geometries, spindles, all this stuff that is irrelevant today. The problem is that if you go looking on the internet, obsolete information lives forever. So I need to drive home that all this stuff about geometry is irrelevant today. UFS does use geometry, but it's not really expected to resemble the disk, and it doesn't use it for anything involving the way the disk is designed. Now, once upon a time, a block and a sector between the file system and the disk were the same thing. When you had that giant IBM Model 350, you knew everything about the hardware, and you had to know it to manage the disk. Now they're not necessarily. So when we're talking about disks and file systems, I'm going to use the word sectors for hard drive blocks and blocks for file system sectors. But even after all this time and after everything has changed, there is one inviolate rule about disks. They lie, even today. And it's not that people set out to make the disk drive lie. It's that engineers did the very best they could at the time. Suppose you could go back in time to the late 70s and you could tell the IBM PC engineers that their master boot record would still be used 30 years later. They would have either laughed and said, oh, that's not my problem, or they would have just given up in analysis paralysis going, oh my God, this has to last forever. And none of that is true. Things move on. Much as, the 64K memory limit became the 4 gigabyte memory limit. Disks had different sizes of sectors. We all may have heard about the 512 byte sector. That's been fairly standard now, but there were 128 bytes, 2K sectors. We finally settled on these 512 byte sectors and everything became 4K sectors. So the software has to cope with that, and you have to be aware of it. And the truth is, even the size is a lie. Are these gigabytes in base 2 or base 10? I know about the tebabyte versus terabyte, but marketers don't do that. Basically, assume that the base 2 or base 10 question is whatever unit is the least convenient for you is your safest choice. So if we don't have geometry, what do? There's this thing called logical block addressing. It replaces cylinders and groups and all of that junk. Every sector has a number. starting at 0. And it basically lets you address the hard drive as an array, a good old-fashioned array with a lot of possible sectors. The disk is no longer pretending to say anything about its innards. So when you are looking at information online and you stumble across something that says, optimize your disk based on the geometry, stop. This is either old information or the person should not be giving advice. Because you will find articles written about geometry and disks this year. And those people need to catch up. So OpenBSD in particular, how do they arrange their storage? Well, like everything else, it's a stack in layers. You have the physical hardware. They have a hardware partition on top of that. That's either GPT or MBR. They then have a disk label on it. That disk label has a disk label unique identifier addressed via a device node, and you put a file system on top of that. And since this is a nice orderly stack, I'm going to pick out something in the middle to talk about first, because it's how we refer to everything. Device nodes. A device node is a logical interface to a piece of hardware or a division thereof. OpenBSD permits device nodes only in /dev. And there are, the name of the device reflects the type of hardware or the type of interface. For most of the disks today, you'll see them as SD devices, which is things that speak SCSI or mostly SCSI. Something a lot like SCSI. And unlike other operating systems, OpenBSD does not have dynamic device creation. You need to create your device nodes. And you can look at devices in a couple different ways. Hardware expects to work sector by sector.
Yep.
They will, that you will send it a block of data. It will write that block to disk. It will say, I have written that block. Give me another block. And so the operating system caches data until it has a whole block and then sends it down to the disk. You can choose to skip that buffer and dump the data to the device immediately. That's called a raw device. It's not commonly used, but a few programs involving working with the disk itself require it, and you only use it if you're required. The method with buffering, sometimes called a cooked device as opposed to raw, is the standard these days. So you've got an OpenBSD machine, you followed the prompts, you installed it out of the box. What is it? What disks does it see? Well, there's a sysctl for that. And here we have the list of disks that the operating system has available. Disk SD0 has that long hex string after it. That's a DUID, a disk label unique identifier, saying this disk is an OpenBSD disk. Here's the unique number. And then there's disks SD1 and SD2 that do not have those labels, so they are not dedicated OpenBSD devices. Once you have a disk, you can look at the partitioning. Now, I saw a lot of older faces on here, so you probably are all familiar with the master boot record, the old standard from the primordial IBM PC. The master boot record occupies LBA 0 on the disk. It lets you have 4 primary partitions, and the maximum size of an MBR disk is 2 terabytes. Past that, we get into GUID partition tables. It's the modern standard, just about everything uses it. And the GPT is put in LBA1. The GUID is a globally unique identifier assigned to each partition. Basically, this is a long random number that in theory should never be able to collide with another GUID. There are people who will make a point of, no, there could be coincidentally a collision. Yes, there could. It is possible. It's 128 bits. The odds of that happening in your data center are minuscule. Now, in case that GPT in LBA1 gets damaged, there's a backup in the last sector of the disk. Now, one of the interesting things about this is that if you take a GPT disk and you put it in a hardware platform that only speaks MBR, well, GPT uses something called a protective MBR in LBA0. It looks like a regular MBR. It says the disk has one partition of type GPT and it fills the whole disk. This is supposed to keep you from accidentally overwriting a disk that you meant to be using. So, and then the first partition on a GPT boot drive is what we call an EFI partition, Extensible Firmware Interface. It uses FAT and it contains the bootloader that helps carry you from the hardware to the operating system. In general, today, use GPT unless the hardware refuses. But just in case, if you have a small system and you need to use MBR, use Fdisk for all physical partitioning tasks. Here we run Fdisk on disk SD3 and we see it is an OpenBSD disk and it has one partition. The geometry stuff is all lies. And the reason I'm going to show you, I'm making a point to show you this, is look at that entry on the second line of the output that says signature 0 by AA55. That means that this disk is conceivably bootable. It is formatted and it is set for use as a drive in the computer. That should be on every drive, whether it's bootable or not. So here we're looking at a GPT, and it has two hardware partitions. The first one is the EFI bootloader, and the second is the OpenBSD partition. And this disk, if you look over at the size and the bottom right of the output, it has almost 2 billion sectors. And that is using 4K sectors. OpenBSD AMD64 assumes all disks have 4K sectors these days. So the reason I brought up the signature is if your disk is blank, if you have a brand new disk and there is no file system, we're looking at a blank disk here, and the signature is 0. So that means the disk truly is blank. There ain't nothing here. And this can be confusing if you say use DD to wipe out the partition table, because the Fdisk shows that there is an unused MBR. There isn't really an MBR. It's just the template that you get to fill out. So suppose you want to create a GPT. You do this on the command line with Fdisk. I'm not going to take you step by step through the commands. I'm just trying to make you aware of some of the things that you can do easily, such as you want to just have a single GPT that fills the whole disk. Sure. You can set aside an EFI partition and leave space for it. You can skip the confirmation, which is great if you're scripting, formatting the whole stack of disks, or set a custom EFI size. And annoyingly, Fdisk doesn't respect block size, and when you're creating the disk, it uses 512-byte blocks. So if you want a 1 megabyte EFI, it's 204,800. Some operating systems will choke on an oversized EFI. So if you're doing something fancy with multi-boot, and you want your spiffy bootloader for that, be sure you check the tolerances of EFI size on all your operating systems before you just say, give me 100 megabyte EFI or whatever. And creating an MBR is similar. Here we make a single partition covering the whole disk. If you're dedicating a disk to OpenBSD, just make one partition. And we'll get to why later. You want the drive to boot? Install a bootloader. And I am assuming with Zoom, and I see the list of people connected, I'm assuming that means you're still here and still breathing. Because the one guy who had a camera on just turned it off.
I'm here.
We're here.
Okay.
We're all good.
Not that I've ever given a mug presentation twice because Jitsi hung up on me and I didn't know because there's no feedback.
We're here.
So disk labels. If you have hardware partitions, why disk labels? Well, disk labels are the OpenBSD standard for partitioning a disk. And what OpenBSD wants you to do is to use a single hardware partition on a disk and then divide up the disk label, the disk partitions with disk label. And the reason this is, OpenBSD is cross-platform. The physical partitioning method used on a AMD 64 box may not be exactly the same as what is used on SPARC 64 or VAX or HIPAA or Mac 68K. So the disk label is consistent across platforms, and the hardware partition may not be. So it's a cross-platform layer. A disk label basically declares which LBA sectors are in which partition. And that sounds like GPT and MBR because they are the same. So let's look at a disk label here. Disk SD0 was labeled, and the label comes in two parts. The opening provides physical information about the disk as well as the bogus geometry, because some software still expects geometry. Here we see this is a SCSI type disk. The label tells you what the hardware is reporting, the model or whatever information the vendor says it should report. There's your DUID assigned by OpenBSD to mark this disk as distinct from any other disk. And the flags field is where your drive will provide debugging information. Now, this was important on the IBM Model 350. Today, modern drives have built-in spare blocks and handle their own debugging. which is great, except when errors start to appear in the flags field, your disk is already toast and must be replaced immediately. At the bound start at the bottom, that's the first sector that you can use for disk label partitions. And here is the big, horrible set of math for a disk label. And most people look at this and go, oh, well, the truth is, this is second grade math, but with big numbers. That's all it is. Partition A is at the top here. If you look on the left, the third line of output, and it has a size of 2 million odd sectors. And it starts at 1024, sector 1024, right after our bootloader. And it's got a file system type of 4.2 BSD and information on fragments, blocks, and cylinder groups that we'll talk about later. But if you look at B, it's got these big numbers here. And yeah, it's type swap, but where do these come from? Well, if you take the size of partition A and add its offset, that is the offset of partition B. That's where partition B begins. So each of these is just added on one after the other. The exception is C because it represents the whole disk. And I've done some digging through the BSD archives because, you know, all the old versions are still online. And they're in Git now, and you can do as much horrible digging as you want to do, you don't want to do. And as far as I can figure, on one of those big old disks, partition A was the root, partition B was swap, and partition C was the whole disk, because that's what you had. There was none of this multiple partitions later because the disks just weren't big enough. If you had users, you would bring in another giant drive. So all of these offsets and sizes are just added together to get the various partitions. The one exception, if you look down here, is partition I. It's an MS-DOS partition beginning at 64 and its size 960 sectors. That is the EFI partition. When you label the disk, OpenBSD's label looks, or disk label program looks at the disk and says, hey, an EFI exists here. I'm going to give it a partition in the label just so you can refer to it and you can mount it. So what are these DUIDs? Why do they have them? Why did they bother to add something? Well, device numbers like SD0, SD1, SD2, and so on, these represent the order in which the hardware happened to find the device when it booted. This worked great in 1979 because startup order was solidly defined. And nobody carried around an extra hard drive in their pocket or their backpack. If you wanted portable storage, that was called punch cards, and you had to get an appointment to have that read in. Today, hard drives move. And a DUID is a unique identifier for the label, and you use it like a device node. So instead of listing say dev SD0 in your file system table, you list the DUID. And that will refer to a particular disk, and that won't move when you rearrange hard drives. So that's partitioning. Let's talk about the file system. Everybody on this call has at some point, excuse me, used some variant of the Unix file system, the old standard BSD file system. Linux's ext file system is modeled after UFS. Proprietary vendors, unless they brag about their improved file system, it was based on UFS. Now, there's not much proprietary Unix anymore, but if you're still stuck on AIX, you'll notice some roots. The nice thing about UFS is it is extremely well tested. This file system has been perpetually debugged for 40 years. It may not have the fancy features you'll find in ButterFS or ZFS, but what is there is really pretty solid. So there are two versions of UFS today. UFS 1 is literally the BSD 4.4 file system plus bug fixes. It has a maximum file system size of 1 terabyte. So it's mostly only used on old hardware. UFS 2 is UFS, but updated for modern hardware. The 32-bit counters are replaced with 64 bits. So UFS 2 should be good for up to exabytes. The catch is you cannot upgrade from UFS 1 to UFS 2. You'll see references to upgrading UFS in the man page, and that refers to upgrading minor versions within UFS from years and years and years ago. I don't know that this feature is even used anymore, and I suspect OpenBSD would take a good look at patches to remove that. On the other hand, there's probably some maniac out there still running actual BSD 4.3 on their VAX and looking to upgrade. So who knows? So UFS has two components, two layers, the Unix file system and the fast file system. UFS contains everything you see, files, directories, permissions. FFS has one job. It gets blocks on sectors. It is about efficiency. Now, at one point, people did research and wrote other file systems on top of UFS. Those efforts have kind of faded with time, and there are layering violations between the two. And most people say they're pretty well entangled today. But if you hear someone specifically saying FFS versus UFS, you're either talking with a file system developer or someone who doesn't know what they're talking about. FFS, in turn, has components. A block is just a piece of a file that gets written to the disk. A fragment is 1/8 of a block, and that's about saving space on the disk. Then there are index nodes, inodes. It's metadata that contains like permissions, which blocks go to which files, and inodes are allocated at file system creation. If you somehow have a large number of teeny files and you run out of inodes, you've got to recreate the file system with more inodes. A superblock is a master index, and FFS keeps a whole bunch of backup superblocks in case one gets destroyed. 5% of space is reserved for cleanup, meaning it will continuously defrag itself and optimize. You can reduce that. It's strongly recommended you don't, because your performance will plunge by about 70%. And when I talked about geometry and I said some bits were still used, this is where they're used. There's this thing called cylinder groups, and they're not used because of the disks. They're used because FFS needed a way to subdivide which indexes handled which blocks. And cylinder groups were just right there. So they said, okay, we'll reuse that, but they've killed most of the other geometry stuff. You want to see what's mounted? Use the mount command. And here we show what's currently mounted on this system. And note, well, and always remember, what's currently mounted might not be the same as what is mounted at boot. If you're having weird trouble, always check what's mounted versus what's supposed to be mounted. And the system learns about all of this from the file system table. And here we have, DUIDs with partition letters saying where things get mounted, the type of file system, the mount options, and when it should be cleaned and when it should be backed up. You'll note that on the bottom, there are two slightly different ones. Some madman made a custom DUID of Bad Code Cafe, and we'll talk about that in a bit. And Deb CD0, my system does not have multiple CD drives, so they're not going to change numbering. But you might notice some unfamiliar mount options. And OpenBSD uses these for security. Things like read-write, read-only, you've probably seen before. But some things that OpenBSD makes heavy use of. These, for example, no device nodes. Intruders love to create device nodes that they own. There's very little reason why your home directory should have device nodes in it. So they disallow them. You can have file systems mounted that forbid execution, that forbid set UIDs. And none of that's odd, but the one that trips up most people is allowing read, write, execute memory. If you take a look back at the file system table here, partition H has that WX allowed option. In theory, a program needs memory, and it should mark portions of that memory as containing the program itself. You can execute that memory and you can read to it or read from it. And then it has memory that it uses as its scratch space. It can read and write to that memory. Programs should not be storing their data in the memory space that they are executing. Your web server should have, say, a copy of Apache HTTPD in memory, and then it probably has some of your web pages in memory. If an attacker can convince the program to load the code he wants and to execute it, then he can execute arbitrary code with the server's permissions. What OpenBSD does in its core system programs is it strictly enforces whether memory can be executed or written, one or the other, not both. And this has considerably narrowed their attack surface. The rest of the world has not followed that example. There's a lot of code out there that when you start tracing what it does with memory. People start to cry and security consultants start to giggle. So, and unfortunately, people want to run a lot of those programs. So they deliberately allow that kind of memory abuse under user local where add-on programs get installed. So let's talk about integrity. FFS is a ledger. Blocks go into sectors, files get written into blocks and fragments. Everything's recorded in inodes. Inodes track directory records. Everything's glued together with superblocks. It is the spreadsheet of doom. It contains a map of 3 blocks and a list of inodes. If you delete a file, FFS goes through the spreadsheet and purges everything. It's no more complicated than it needs to be to track millions of files across billions of sectors. Unmounting the disk when you shut the system down or you want to eject your flash drive means completing all the outstanding writes, unmounting it, marking it as clean, and freeing the disk. If you interrupt this process at the wrong moment, the ledger becomes internally inconsistent. It needs integrity checking. At boot, OpenBSD mounts partitions as per etc tab. If a file system isn't clean, it isn't marked as clean, it preens the file system, which means it fixes inodes that claim they're used, but there aren't any files, free map listing blocks that are in use, and it errs on the side of preserving data. So this cleans up some minor things that could happen. If preening doesn't work, it gives you what a completely backward error message. The file system may be mounted read-only, but if you want to use it, you must run FSIC, the file system integrity checker. So how does that work? Well, there are 4 things you can do to repair a UFS file system. There are the file system debugging tools, FSDB and CLRI. And using them is like building a pig out of a truckload of sausage. There are people who can do that. I am not one of them. I've been using UFS since the mid-90s. You can run FSIC manually and approve every change. You can run FSIC automatically. This is what I strongly recommend, because running FSIC manually is basically having a friendly front end to the debugging tools. And there are billions of files with billions of possible errors. Or you can just restore from backup. So those are your options. I would tell you automatic FSIC, and worst case, be prepared to restore from backup. OpenBSD and the BSDs in general have this feature called soft updates, and it arranges disk writes so metadata remains consistent at all times. And this is a performance improvement, and any errors that happen after a bad shutdown can be autocorrected. Now, it's not journaling. Any errors that happen after a bad shutdown can be autocorrected. Does not guarantee that the disk, that your data was written to disk. It means that the file system will be clean. Now, a size 0 file is correct. It parses. Now, given that, should you use it? Well, for modern AMD 64 systems, I would say yes. Modern hard drives have tiny write caches to help finish out the final writes in case of a power failure. If you're on a minuscule system with tiny memory, no. On the other hand, very few people are writing important data with their Raspberry Pis. It does happen, but so those are the real file systems. I'm going to go on now and talk about things that look like file systems but aren't. One of them is swap space. Swap space is on your disk like a file system, but it's super slow RAM. It's super slow memory. When a host runs low on memory, it shoves objects that haven't been used into swap. And there's two different ways to describe that frequently get used interchangeably, but one of them is okay, one of them is not. Moving bits and pieces of a program into swap is called paging, and that's fine. There's an adage that a program spends 80% of its time running 20% of its code. If you start up your web server, the whole thing gets loaded into memory, the startup routines run, and then the startup routine and the shutdown routine just sit there until they're needed. Well, that crap can just be shoved into swap and nobody cares. Now, if your server is in catastrophically short memory, it does something called swap, where it runs the entire program into swap. And then at the next context switch, brings the whole program back up off the disk. This is catastrophic and horrible, and just reboot your machine now, you're doomed. Well, and then on modern systems, people ask the obvious question. You have all these gigabytes of RAM, why would you even need swap? Well, programs are greedy. And also, if you should discover that somehow you managed to panic the host, kernel dumps get written to swap. Even if you don't want swap on your active system, you should have swap space available so that in a panic you can dump to it. Now, OpenBSD encrypts swap by default, and there are new keys at every boot. So after a reboot, an intruder is not going to be able to read data from the previous run. There's also this thing called memory file systems, which is kind of the opposite of swap. Any media that can hold data can be a file system. You know, punch tape, magnetic tape, whatever. It holds data, you can noofs it. A memory file system is much faster than spinning Rust. A memory file system uses a chunk of RAM as memory. It's much faster than spinning Rust. It's only marginal improvement over SSDs, and it disappears at a shutdown or a panic. Really, what you would use MFS for today is fast-changing, short-lived lock files in a big database-driven application. And it can be useful even when using small amounts of swap. Those short-lived lock files are probably more important than the application's startup and shutdown routines. You'll also see the man page for Mount Tempest, which is something else entirely. And this is, MFS calls for careful juggling when your system is short on memory. If you're doing some swap, you're using some MFS, basically it's the old system administrator dance of you get to choose your pain. OpenBSD also supports various foreign file systems. The usual suspects like FAT, UDF, CDs, and it also supports other file systems via Fuse. Sometimes you have a choice between integrated mount commands and Fuse support. Look at the features each supports and choose what's ever right to solve your problem. And when using other operating system disks in OpenBSD, ownership is always an annoyance. A file system like FAT has no concept of ownership. So you have to assign an owner. A file system like NTFS has an incompatible ownership scheme. So again, you have to do some manual mapping. Or what's perhaps worst is something like EXT, where it has a similar Unix permission scheme, but it completely clashes with your etc password and none of the user IDs match up. So take care about ownership. OpenBSD also has good support for the network file system. Now, NFS is the primordial file system sharing tool, lets you share between systems. Now, have to be running port map. It uses almost 4,000 TCP and UDP ports and related daemons scattered on other ports. NFS is stateless. The server and client send and answer requests, but none really have an understanding of where the real transaction is. Access control is by IP, UID, and GID. So fairly primitive. And if you want to learn UFS, just get a VM and resign yourself to rebooting early and often. Now, services like RPC StatD add stateful elements, but proper file locking in protocol isn't possible. There's this thing called RPC LockD that kind of works around it, which OpenBSD supports as a server, but not as a client. Basically, NFS was written in 1984 and looks like it. However, it is highly interoperable, not guaranteed, but pretty sure. Now, NFS has 4 versions. Version 1, internal to Sun, you'll never see it. Version 2 was where they opened it to the world. It's UDP only for low loss networks. It's not recommended today, but it is the lowest common denominator. If nothing else works, NFS version 2 probably will. NFS version 3 is an incremental improvement. Has the locking workarounds, some of the hard edges smooth, TCP support, so works better over the WAN. There is a thing called NFS version 4. It has no relationship whatsoever to those earlier versions. OpenBSD doesn't support it. Now, NFS version 4 was designed for compatibility with Microsoft file sharing, CIFS, and that whole non-Unix permission scheme. So, OpenBSD is not likely to support that. So, iSCSI is another approach to file sharing that OpenBSD supports, where instead of accessing a file system, you access block devices. And you administer those block devices via SCSI commands. Everything looks like a local disk. Now, the problem with iSCSI really is one of, for most cases, speed. Now, your 6 gigabyte SATA connection, well, that's 6 gigabyte is 48 gigabit. And very few of us have a 50 gigabit network card to dedicate to one iSCSI connection to get the same performance as a local disk. So can this be done? Yes. Is it going to give you high performance? No. But it may be a better solution than other things. And OpenBSD's support for iSCSI is kind of minimal. Now, one place where OpenBSD excels is their software RAID. Now, hardware RAID looks easy and it's risky. You can go and buy a RAID adapter and it has a pretty menu, and you just go click, click, click with your mouse and boom, you have RAID 5, yay, we're redundant. Except that that RAID is provided by, that hardware RAID is really software. It's just the software is a black box and you can't see it. And again, in the general Hitchhiker's Guide to the Galaxy theme, if you can't see peril, it's not going to upset you. So there's nothing to worry about. RAID cards are not interchangeable. They use proprietary formats. If your 5-year-old RAID card dies, good luck finding another one. You'll be haunting eBay and paying top dollar because the people who have them know why you need one. Now, software RAID looks hard, it has these complicated command lines, but the format is open and interoperable. And if OpenBSD ever changes their soft RAID format, there will be a migration path to take it forward easily. And OpenBSD supports software RAID through their soft RAID interface. And there are 6 different types of RAID they provide. Stripe just dumps 2 disks of the same size together. There's no redundancy, but it's bigger. The concat type of RAID dumps 2 disks of different sizes together. It gets you a lot more space. There is no redundancy, and the performance is exactly as lopsided as you might expect, but it's big. RAID 0, mirror. OpenBSD can boot off of a mirrored drive. RAID 5, with parity checking, can't boot off of it, but it works well. There's the crypt discipline, which is encrypts a single hard drive, and that's bootable. And there's the 1C discipline, which is mirrored encrypted bootable drive. So, encrypted storage. Now, you may have heard me rant before about, and most people don't need encrypted storage. And I'm going to expand a little bit on why that is there, why I do that, but I'll take you through this first. Encrypted storage only protects data at rest. Once the machine is booted, that your data is vulnerable. So consider your risks before just saying, oh, I'm going to encrypt my laptop. Because I keep seeing this pattern. Sysadmins love new tricks. We learn them. We have to implement them. And our systems have all these new tricks that are beautiful and lovely. And then we overload on them and implode and forget something critical and everything falls apart. So, and we wind up, revoking our SSH keys and carrying on. So, are you gonna do that? Are you gonna let yourself be overly complicated and then crash? Now, if someone steals your laptop, do they want your data or your hardware? Are you really carrying data that people are going to want to steal? And that depends on who you are and what you're doing. Now, I tell everyone to have a unique set of SSH authentication keys on every desktop or laptop, every client system. And if my laptop is stolen, I will say, damn it, I will revoke those keys. I will go through elsewhere that may have trust relationships with that laptop and mark it untrusted, and I will carry on because nobody is going to steal my laptop unless they are looking for, half-finished books. And that's really a very small group of people. But some of you do need it. Personally identifiable information like healthcare workers. If you got that on your laptop, there are laws, you got to encrypt. Relief workers in war zones. Laptop encryption will not save you, but it may save your colleagues working in other parts of the war zone. You may be working on proprietary designs, and those must not be stolen. Sure, encrypt the laptop. You may be subject to regulations on data destruction, and one way to easily comply with those is to encrypt your server hard drives at installation using a physical key to decrypt. That way, when it comes time to decommission the server, you pull out your USB key that is your decryption key, and you beat it with a hammer until it shatters. Your data is now unrecoverable off those drives. You can throw them out. So if you want to learn disk encryption, or if you work with nosy people who want to prove how smart they are by pillaging your hard drive, back up your data and allocate attention to managing that complexity. Now, OpenBSD's disk encryption is considered computationally unbreakable. It's on a par with industry standards. But I would remind you that where practical and computational analysis ends, that's where rubber hose cryptanalysis begins. Anyone with the right attitude and a pointy stick can have all of my passwords. Because if they really mean it and they're going to commit violence on me until I surrender, here you go. So consider what you have to protect and decide if you want to work with that kind of data. That's always one of my questions when I'm interviewing for a job is disk encryption required? And if so, why? And if the prospective employer answers wrong, I thank them kindly and turn them down. Also, the phrase full disk encryption, it is a lie. The disk is not fully encrypted. No matter what, you've got to find the partition. The hardware must be able to find the partition table so that itty bitty bit of the disk is not encrypted. However, marketing can't sell practically all the disk encryption. So here we are. So I forgot to remove the note about Penguicon from my Q&A slide, but that's the end. I have the book on hand, and I'm going to stop sharing and take questions and answers.
I was
So
going
you
to say,
can
just had a comment about the why all the extra tricks that we put on our computers. I mean, that's a good point you make about where it's full disk encrypted. Look, it's all locked down. And then you're like, well, what are you protecting? You're like, oh, I don't know. It's just a new trick. I like to do it now every time I install my laptops. Yeah.
Oh yeah, there's nothing. We're in this business because we like cool new tricks. Yeah. Decide which tricks you're willing to put up with.
Yeah, invariably, it seems like an evergreen thing where somebody was like, "Oh yeah, I encrypted such and such," and it's like, and then something went horribly wrong, and now I have no data. And it's
Yep.
like,
Well, and that's a vital learning experience.
yes.
I mean, you got to warn people.
Mm-hmm.
You warn the kids, and because there is a joy in saying, "I told you so." and then helping them recover and saying, okay, are you going to do that again? And you
Yeah.
know, if they do it again, maybe this is not the career for them.
Well, no, I think it probably is the career for them. It's just that they may want to choose a different approach. You know,
Perhaps.
it's the old you know, fool me once, shame on me, fool me twice, shame on me again, fool me 3 times. I guess I'm really not cut out for this sort of thing. Any questions?
Yeah,
I
it's
just want to
Go.
make a comment. I like what you said about RAID 5. RAID 5 is basically not secure based on what you're saying.
Well, security, that's, to paraphrase another piece of pop culture, you keep using that word. I don't think it means what you think it means. It provides a certain level of redundancy for a certain purpose.
Yes, I agree with that.
And interleaved correctly with other sorts of redundancy, it's lovely.
I think the main thing thrust that you were saying though about RAID 5 was not so much about the RAID 5 technology as it was about proprietary cards.
Mm-hmm.
Like I know on my my motherboard here, it's got its own version of RAID, and
Yeah.
I will never turn that on. I will prefer the Linux software RAID because the Linux software RAID I know is at least compatible between different kernel versions.
Yes. Yes.
Whatever gigabyte happened to or ASUS threw on there, I don't even remember what the motherboard is. It's an ASUS. Never mind.
Yes.
Is pretty much going to be just for that particular motherboard. I'm not going to probably see it anywhere else.
Yep.
And that's the major problem is if you use something like that is proprietary either to the motherboard or to whatever card you're using, then you're basically stuck with that card in perpetuity as long as you're using those disks and that data.
Yep.
You know what, though? I'll make an argument for hardware RAID. You set up a rack with servers in it in a data center. Take a Dell, an IBM, an HP, whatever you want with hardware RAID. It's just dead simple to replace a drive. There's no software commands. There's no nothing. You pop out the failed drive, pop in the new one. Any idiot can do that.
It is that simple until the controller has a problem.
Yeah.
Right, but you got to back. I'm talking big server setups. You know, you're sitting at home with your little machine under your desk. Yeah, great. Go with software RAID. That's a great way to do it. But in an enterprise environment, hardware RAID is perfectly fine.
If your enterprise is willing to invest the money. Now, Jim, I know you run your own company.
Yeah.
You know the risks. I'm sure you
Sure.
have spent the money.
I spent probably more than I should. Yeah.
Well, more than you should is probably what you should have spent.
Yes.
In my environment, that's the only way I'm going to do it. You know, if I need to send a Dell tech out there to replace the drive for me, fine. And yeah, there's a premium to pay.
There is, and
there's a place for hardware RAID, and that's all I'm saying.
Yeah, and you are spending the money to do it.
Yeah. Well,
and you said no, we're going to hire it. We're going to have the vendor. They're going to come and get it, and I'm also confident that because I once had a Dell. I once had a Dell BIOS bug where the wrong light lit up on the RAID array for the failed drive.
Right.
My
so they
my
replaced
poor
the wrong
flunky,
drive, and
yeah.
Then you're
Suddenly we
done.
had 2 bad drives in the array,
Sure.
and I'm sure you also have backups.
Oh, absolutely.
And you are
I'm
putting
glad that
time and attention into. You have a flunky whose job it is.
Yeah.
Well, that would be me, but yeah.
Okay.
Yeah.
Yeah, you're making sure things run, you know
Yeah.
the risks. The last car company I worked for had a just-in-time policy for everything, including disasters.
Oh,
And
that's
this
not
was
good.
a major automotive supplier.
Okay, just in time. Just in time is fine for maybe like, okay, we need to order such and such parts and we don't care when they show up. Just in time is definitely not a disaster plan. That's like, you
No.
know, when the disaster happens, we'll figure out what we need to do at that point. It's like, no, sorry. that's not a plan. That's basically making it up on the spot, but with extra steps.
Yeah.
That's like throwing away the plan for what happens if there's a terrible communicable infection
Yes,
previous
Yes,
administration put together.
Yes.
imagine that.
Abolishing
No,
the team responsible.
well,
But before we get too far into that, Roller, you seem like you had a question.
Yeah, the I just want to comment on the whole full disk encryption. The argument that gets made is all of our data is encrypted, but then you decrypt it and run the server and all the data is not encrypted. And it's so insane to hear the salesman people sell this idea, and then you're sitting there going, what is he talking about? Because the key to unlock the thing is also on the system. And how, I mean, are you going to load it every time? They're like, no, it just decrypts it on boot. And you're like, oh my gosh, what's
Yep.
I'm in the healthcare business. My database is sitting on an encrypted set of drives. It's a bunch of RAID drives, a bunch of drives in a RAID array. That's an encrypted file system. When I boot that system up and I mount the file system, I have to key in that. It's not that key is not sitting on the drive somewhere. I actually have to key in that passphrase in order to unlock that file system so that I can mount it. But I think that's the way to do it.
Yeah,
And I'm required to do that because, like Michael said, HIPAA compliance and all. It's data at rest has to be encrypted.
I agree.
It's not encrypted when it's spinning, but
At least
that's a different set of issues.
yeah, for like a jump box scenario, I like the idea of the keyed in full disk encryption setup where if you want to boot this thing, you have to go to the console, you have to, and then it works, and then you can do what you need to, and then shut it right back down.
Yeah.
Yep. But then you need processes in place. Is what one of my personal rules on systems is that I have to be able to go on vacation.
Yeah.
And especially, with poor Jim and HIPAA and all of that, he has to comply with some things to make that happen.
Yeah, and I agree with them too, but
Yeah.
I mean it's a part of my world.
Yes, you are paid to have that headache.
Yeah.
Yeah.
Well, it seems to be with a lot of these things. It's kind of like those realtor lock boxes that they put on the front of homes and whatnot to has the key is ready right there.
Yeah.
And then putting some dino tape on the bottom with the combination, like.
Yep.
Well, yeah.
Because I've long said that I can never be one of those cybersecurity professionals because I am not nearly paranoid enough, and I do not have the bandwidth to think that far back of all the various things that people can do in order to basically, find the screws in your pool building and take the handles off rather than meddle around with the lock, sorts of things.
Yeah, those conversations are fun. I was in a debate. They pulled in a couple other guys because it didn't sound right, and they were like, "Is there a way that someone could get access to this system?" And I'm like, "Yeah." And they're like, "Hold on, we don't know if you're seeing the whole picture." And they asked these other guys, they're like, "No." And then I just shared my screen, and I'm like, "Okay," and because they just weren't seeing the PKI.
Yeah.
They weren't understanding that the whole thing was based on PKI, and if I had a copy of the private key infrastructure, I could just mint myself a new key.
Yeah.
And they're like, well, no, but the system will check to verify. I'm like, yeah, but it just is seeing, does this key come from the same place that my key came from? You know, and they're like, that doesn't sound right. I'm like, yeah, basically we need to remint this thing, because if you don't trust the guy who originally created it, make another one.
Yep. Well, understanding PKI is a whole different.
Yeah.
Oh,
Hey, that's actually the cover of your book about it too.
it is. Yes. Oh.
I like that book too, because it was so eye-opening about just the madness.
Yeah, you're doomed.
Yeah, and then there's a certificate replication list that you can check. Oh, but no one ever checks it, and people just DDoS those guys. And
You know, we want to know the truth. You know, we're responsible for these systems, and the fact that something like the certificate revocation list exists is great.
Mm-hmm.
But, you know, tell us the truth about how it's used. And there is, our whole industry has a lack of completion. We're happy that a certificate revocation list exists and don't think to ask, when is it checked?
Yeah.
You know, and that's, I'm
Right.
going to use Jim as the,
Is it checked?
or
Yeah.
these users are on the certificate revocation list, therefore they can't ever get in. And you're like, unless they make themselves a new key. They're like, what? What are you talking about?
yeah.
Or they use someone else's key that they gave to that person because they minted the key for that person. And who's to say they didn't keep the copy of it?
Yeah.
So are there any questions about file systems?
Yeah.
Because we could have a whole discussion about all this other stuff in the after dark.
Yeah.
So I do have a question. Can you hear me?
Yes.
Yes.
Yeah.
So,
Yep.
getting into the cloud stuff now. So you're taking your virtual machine, and your virtual machine knows all the stuff about the file system, as you've been talking about, but then it lays it on top of God only knows what, whatever that vendor provides, right? And
Yep.
so I don't know if there's like anybody moving toward standards that would make it easier for cloud services to provide, you know, file systems that the operating system is going to understand, or if this is just the Wild West and will continue to be that way until stuff starts to break more.
Well, yes, this has been considered. A couple different, you're talking about complete virtualization versus thin virtualization. Did I give a talk on jails to Mug?
Yeah.
Yeah, go back to that talk.
I think we were at the library at that time. So that's,
Yeah, I think it was in
that's more
person.
than 3 years ago.
Yeah. There are virtualization systems that are aware of the underlying file system and take advantage of them. But if you want to do full virtualization, as in plop in the install disk and install the operating system from scratch, then it's going to be layers of file systems. Or you have something like a ZVol, which is you run your file system on top of a block device provided by a lower layer.
Okay, thank you.
Just a quick question. When you showed all the different types for mounting,
Yep,
if you mounted one with the no A time, does that just makes it so if you touch a file, it doesn't update the timestamp or anything like that?
correct.
Okay.
That may, if you are writing to a file system, but you don't care about recording, sorry, if you'll be reading from a file system, but you don't care about when the last time you looked at it was, no A time is fine.
It's a good idea for NFS file systems.
NFS, yes.
Yeah.
Because why increase the network load, right?
Why is just a great word around NFS.
Well,
I use it all the time.
yeah,
I,
it solves a problem.
It does. It does. I have a you've heard of love-hate problems, or relationships. I have a tolerate-loathe relationship with NFS.
Yeah.
It's
the thing
great.
the thing that I found with NFS as a file system is that, yes, NFS is imperfect and we live in an imperfect and fallen world, but everything else that I've tried is worse measurably.
Yes.
Yeah.
Yes. Well,
When I was doing LTSP, that we mounted the root file system NFS. That's- I mean, without a hard disk, without a local drive, what else are you going to do?
I'm okay. I'm an old BSD guy, so Sun Microsystems, Bill Joy.
Yeah.
He knew what he was doing.
I mean, the fact that
Well-
we're still talking about NFS and it's had 4 revisions thus
Yes.
far, and we're still on revision 4, and
And it's-
nobody has come up with R5.
Yeah.
Well, that's because nobody has adopted R4 yet. A handful of people have.
Explain.
Okay. NFS v4 is designed for interoperability with Microsoft file sharing.
Oh, I see.
If you want to serve files via Microsoft file sharing, the smart thing to do is get a Microsoft file server, put it on your domain.
Yeah.
I mean, I love my Unix, don't get me wrong. I mean, but providing a Unix system to serve CIFS to Windows clients is solving the wrong problem.
Yeah. No, I get what you're saying there. Because although, I mean, so my Synology RAID says that it supports NFS v4, and I'm wondering if that's just more, it supports it in a Windows context if you're using it, but why would you?
Yes, yes. I would. I did a lot of when I wrote the FreeBSD specialty file systems book. NFS v4 is one chapter. NFS v4 access control lists is another chapter.
Yeah.
And out of the like 14 chapters, those 2 took longer to write than the rest of the book.
Yeah.
And I had John Hickson, who was very generous with his time. He worked at IX Systems. He later moved to Red Hat to handle their NFS v4. He spent hours with me attempting to bend my brain around this. And now, to be fair, he said it was pure self-defense because he wanted a good book on the topic because none existed.
Mhm.
And he really wanted
He
to
had
just
a
tell
motive
people.
for helping you, yeah.
Yeah, yeah.
And he didn't want to write the book,
Oh, God, no. No, his
Yeah.
life was still worth living.
right? Does anybody use Samba anymore?
Yes,
Remember that old thing?
Yeah.
Yeah.
Really? I just never hear about it anymore.
because it just works.
It just, I was gonna say, mine just works fine.
Wow.
I
We
use
had
I
it.
haven't touched it.
Yeah, we
I
had
haven't
it at
touched it in 15 years.
You
Yeah, my-
you You can mount it on your iPhone. You can mount it on all these little things that try and access your shared storage.
Yeah.
Yeah, I use it for NAS.
Wow.
The only thing that I would recommend if you're using it in a Windows context and you happen to have Active Directory somewhere in there, is to get yourself a Microsoft Active Directory server to do all that stuff, because we had that in my previous job, and it was doing the SMB stuff, fine, whatever, but Active Directory is its own little beast, and we were using some kind of LDAP
Right.
thing,
Right.
and everything got very complicated.
Yeah. LDAP on steroids.
Mhm.
Yeah, basically you just pick a user that you want to map a share to, and then when they log in, you have to like map the user that you created for Samba and then the user that you want it to map to,
Sure.
and then it works.
Sure. I did tons of Samba years ago. I just haven't even heard it mentioned in 15 years. I guess it just works.
Yeah.
It's kind of like Apache.
Yeah.
You don't hear anything exciting about it, but
Yeah.
it's there, it goes.
Some smart guys wrote that stuff.
I do.
Yeah.
Now, to be fair, if I was seeking out a web server today, I might decide differently.
Yeah.
But I learned how to use it in 1996, and
Yeah.
It's muscle memory.
yeah.
Yeah.
Any more questions on file systems, since we seem to be going down every other rabbit hole other than
So Michael, when you talked about the WX allowed mount option, and you were talking about where to use it and where not to use it on OpenBSD, what could you talk more about that? Why was it mounted in /user local?
Okay, on BSD, well, Roller, you know this, but for the Linux people in the audience, user local is where BSD operating systems install add-on software not included with the core OS. Draws a firm line between the OS and the user land. Sorry, between the OS and the add-on stuff. Linux is more, here are all the packages and install whatever you want, and they all go in /bin, enjoy. Or sorry, user bin, still enjoy. The OpenBSD operating system is carefully audited so that if a program in the main operating system attempts to write to executable memory, it immediately crashes. They have this system called Pledge and Unveil, which controls what resources they use and what kind of memory, and it's really is lovely. So other programs do not undergo that kind of audit, do not necessarily undergo that kind of auditing. So OpenBSD says you can install those programs at your own risk, because they know perfectly well folks want to run Apache and MySQL and Nginx, and they cannot force the world to comply to their standards. So they allow programs run from that mount point can write to their executable memory.
Oh yeah, okay, that makes sense. So they're just saying if you install an add-on, it's going to go in user local, and then they can do what they need to. But the rest of it wasn't in any of the other mounts.
Right, because if it's in the OpenBSD core system, it better not be writing to executable memory. if you're running, oh, say Netcat, or no, what's a good program that runs with root privileges? Ping. Ping has to open that socket, that privileged socket, to send the right kinds of packets and handcraft those. If you could, in theory, handcraft a malevolent ping reply and load that into the ping's execution space and have that run as root. I'm sure someone has probably tried that at some point on some implementation, but OpenBSD just says, no, that doesn't work. You can execute or you can write, one or the other. Any other questions?
I just posted a quick little link out there in Slashdot, and it's about China trying to, so I guess we've been talking a lot about using Linux to restrict access, lock things down. But what about the other way around? If you say you're a government entity or you're a company and you want to make sure that you have access to the data, is that something that can be set up, or is it pretty much whoever has access to the system can encrypt everything and lock it so that nobody can get to it?
Oh, this is a long-running war, and this war will not end in our lifetimes. Not as long as we have general purpose computing devices. Yes, you can configure things so they can't find it. They
Battleships. Oh, Battleship 20.
they will figure out a way to find it. They'll figure out another way to share. They'll stop sharing. Yeah. On and on, world without end. Amen.
By the way, where are you? Because it sounds like you're near Hellmouth whenever you unmute.
I think he's at a Taylor Swift concert.
It sounds like that.
My wife is watching one of those performance shows
Okay.
where they have the amateurs come out and
No
sing
worries.
stuff. So
No, is it just the way that it's set up? It sounds like it's Doppler shifted, and it just sounds like the voices of.
yes, it's in the next room, and we have these heavy walls between us, but it's like an open ceiling kind of room. So
No
that's
worries.
going to distort it and make it sound interesting. But there was a really cool guitar player on a little while ago, so I had to leave and go listen to that. But other than that, it's been
No worries. No worries.
no problem.
So I have a question on NFS.
Okay.
If you're in a complete Linux environment, would
Yep.
you use NFS version 3 or version 4?
I would have a strong bias towards version 3, with the caveat that if you were sharing over a slow WAN and you have globally integrated authentications such as LDAP and Kerberos, you might look at NFS v4 for performance, but look at, I would tell you to retain the Unix permissions scheme and only use version 4 for transport. But whereas NFS version 2 or 3 uses UID and GID for identifying users.
Right.
Version 4 uses usernames for identifying users, which means I log into my workstation as, C. Maloney, and suddenly I have full access to his, his source repo, and 6 months later, when that critical bug comes out and it's attributed to Craig,
Mhm.
I mean, we all know Craig is responsible for the bugs anyway, but
Oh yeah. In some ways, so I can totally see where having a username with an authentication and all that stuff backing it up would be better than having, user 1000 on every single little, Ubuntu machine that got installed throughout the
yes,
entire company.
yes, I get it. And yes, I can make any UID I want on my machine as any user, but I can't necessarily authenticate that to the network under NFS-v4.
Right.
So it does have that stronger authentication. Especially you throw in some of the stuff like Kerberos, and then you have an authentication department. And I mean, I know folks who do that, but there are, companies like Yahoo, where their servers farms are large enough that they ran out of UIDs.
So for us normal people who are just saying, I want half a dozen Linux machines in my house on my gigabit internal network,
Oh
where
God, no.
I'm creating my usernames and giving the UIDs and GIDs the same because that's the only way I can logically keep track of myself.
Yep.
NFS version 3 and throw that on my NAS and I'm good.
You are done.
Okay.
Yeah, you're absolutely done. You could do version 4 if, well, remember the thing about encrypted disk and tolerable complexity. If you are keeping UIDs identical across systems, and it's not quite the same as using LDAP, but you might get away with NFS-v4. And I believe some Linuxes default to NFS-v4. So
I think I have experienced that because I tried to mount an NFS file system that was really, really old, and I had to tell it to mount it as version 3.
yeah. The important thing is you know what you're using and are prepared to cope with it. And if it gives you results you hate, change it.
Yeah. Okay. Thank you.
And really do what works for you. Everything is terrible. Computers were a mistake. We're doing the best we can.
Well, I think that a lot of this knowledge gets passed down from generation to generation. So I think that's part of a lot of these concepts keep getting life and whatnot. And some of it, of course, is valid and still valid throughout. And then things like, worrying about disk geometry get passed from generation to generation. It's like, if you've worried about disk geometry in the past 10 years, you're probably doing it wrong.
Yes.
or you're a retro computer enthusiast, one or the other. I'm not sure.
But modern hardware, you should not be thinking about geometry.
Yeah. One point that I'd like to highlight, you mentioned about swap. I had it explained to me by someone that I trust that, because I was like, oh, just keep everything in memory. I don't want to worry about swap. I don't want to have to sit and wait about all this stuff. And his idea was, actually, this is the stuff that you don't use very often. So why not keep it somewhere where it's not being used? It's kind of like the closet, it's you throw things in the closet that you don't need. And whenever you need it, you go run over to the closet and grab it and then get it out of there.
Yeah.
It's not in your living space. Yeah, exactly.
Why do you have the garden shovel in the living room?
Exactly.
Well, I was playing with non-volatile memory for a while there, which is like a real high IOPS storage device.
Yeah,
it works like memory, but it's, like disk storage. So it's kind of this interesting thing. And I don't know the difference between the speeds and things with swap and, have actually in memory and having in this thing that looks like it might be memory, but is actually not. Just it'd be interesting to see some statistics on that.
Are you referring to things like tempfs versus having it be like in buffered cache or anything like that? Is that what you're asking?
Non-volatile memory is physical chips
Gotcha.
that
Okay.
are put onto the actual back plane of the motherboard, so they have
Gotcha.
You're
direct
talking
access
about, like,
to
like
non-volatile.
NVMe.
Yes, NVMe,
NVMe. Yeah,
non-volatile
sorry.
memory.
I got
yeah,
confused
those
for a
things are
second.
fantastic.
Yeah, so it's hundreds of thousands of IOPS, and it's supposedly extremely fast. And I'm sure that but it's a little bit more expensive, so you have to sort of weigh the costs versus the benefits. And the systems today have a limit of how much you can put into this, that type of thing. But still, there's got to be some trade-offs in terms of here's your memory, here's your swap, here's this non-volatile stuff, here's some SSD, here's some spinning disks, here's tapes, and someone I'm sure would make that a chapter in one of your books or something.
well,
Well,
ZFS.
swapping over NVMe will never be faster than not swapping,
Huh.
right? It'll never be faster than just having enough RAM in the system. So if you can have enough RAM, but if you've
Yeah.
got portions of your computer portions of your program like startup that run once and then you don't need, if those virtual pages get paged out to disk, no big deal, right? They ran once.
Well, and ZFS has this concept of tiered storage, where it'll literally rank the speed of the devices. So you can say, we're going to write to the non-violent
Yeah, volatile. Yeah,
non-volatile RAM
there you go.
first. And then as IO permits, we will move it to this slower medium.
Sure.
It's yeah. Choose your headaches.
Yeah, right.
That sounds like some more manageable complexity.
Right. But if you can put a database on NVMe, holy moly. I've got a customer with 12 terabytes of NVMe and they're running their Postgres database on that. And it's just butt kicking fast.
Isn't that because of all the extra queues? Doesn't it have like 30 plus queues that it can?
I think it's a lot of things, but
yeah,
it just runs circles around anything spinning.
Yeah.
Yeah.
I mean, if you got $3,500 to allocate to this, I just looked at the first thing, bytes of NVMe, and it's like, holy shit.
Yeah.
I bought
I think they spent about $20,000 on the storage for this thing.
Yeah.
But it works.
It's yeah. I love it.
Well, this also gets back to your earlier comment too about IT folks. Some people like to scrimp and save and whatnot, and so they're using desktops as servers and all this other kind of crap.
Sure. Right.
And it's like,
doing it enterprise level when you're when your business depends on it.
Yeah, is definitely the way to go on all this stuff.
Sure. I mean, this place they'll do a couple of MRIs, and that'll cover the cost.
Oh God,
yeah.
So, do what it takes to do it right. And I realize, at home I don't do that.
No, God, no.
Me on my home systems,
I mean, my machine here still has spinning Rust in here, for God's sakes.
Actually, my MacBook Pro probably has NVMe in it. I don't know, but
yeah.
I have I bought a new computer to write this pretty storage book, and for the record, it is very pretty.
You should promote it.
It is. It is.
And it has 2 NVMEs, an SSD, and a spinning disk.
Nice.
And the difference between them is really palpable
Sure.
in the experience of using it. I had thought the NVMe would be about the same as the SSD, and it's not. It's user visible.
It's right on the bus.
Yeah.
It bypasses the whole PCI and everything. It's just very, very close to the CPU.
Yes.
It's nice.
Yeah, I
You can
brought
get those.
this.
You can get those little
or what's it called?
ITX things.
No, it's not called Latitude.
What are those little ITX boxes? Maybe it's not ITX. What are those little Intel NUCs?
The NUC.
Yeah.
Yeah, those have NVMe slots on them.
We're
Like 1 or
going to
2.
see more and more of that.
Yeah, and for $400 you can get a, I don't know how many gigabyte NVMe card for it.
I got
Less.
terabyte
Yeah.
Yeah,
NVMEs for less than that.
yeah.
Yeah, I brought the Dell Precision 7760 to BSD can, was showing people it has 4 NVMe slots on it. And I turned that laptop into, it has a Xeon processor. I was like, this thing is a beast. And you can pick them up refurbished because people, I don't know if Dell just didn't sell enough of them or what, but they made
Well,
it.
they might have come off lease,
market. Yeah, they made it for like an architect that wants this as a super workstation, and then I just don't think they sold enough of them, because when I got mine refurbished, it was brand new, had all the plastics on it. You could tell it's never been booted up. But eBay, 100% certified refurbished from Dell.
And Gib just posted terabyte NVMEs for $44.
Nice.
There you go.
Dang.
Keep in mind, you
Oh.
get what you pay for.
You do?
Yeah. I'm not going to plug those into a enterprise server,
No, but there's
but
the
I'd
whole,
put it in a NUC. Right.
it wasn't that long ago that you really had to watch SSDs for, write degradation
Sure.
and failures, because they were not, we didn't yet know how to make them well.
Mhm.
And I think the $44 NVMe is it's a sign that the more expensive cards, we figured out how to make them better.
Yeah, I'll submit there. So I have an SSD drive in my laptop that I got a long time ago, and it's still kicking it. I think it's like, maybe 10 years or something like that. It's still going strong, but it was one of those Intel ones that had like the super redundant chips in it, as opposed to some of the things that you get nowadays where it's like, it's pretty much at capacity. And if it so much as has a fault, oh, well, you're done.
Yeah, so we're, it's the same old evolution. Well, guys, I have not had my supper yet.
And we should probably wrap this up. It was a fantastic
Yeah.
conversation.
Thanks
You
for
know, it's always good to talk with you. Any last questions?
I have one. Since you're an old guy and I am too, I remember back in the UFS days on Sun Solaris 2 that we were concerned with cylinders and how we partition things because it would make our file systems faster by reducing head movement.
Yes.
Then we go to the logical block thing where it's just a string of blocks and we don't care anymore.
Yep.
Are the disks that much faster now that we don't need to care about that to do optimization? I mean, we still have heads, they still have to move.
Yes,
How
we
loaded
do.
a question is this? My God.
Well, here,
Yeah.
this is okay. Back in the SunOS 2 days, with actual Sun hardware. And remember, Bill Joy. That's a name to invoke with in our business. Those hard drives, you knew what the actual geometry was in them.
Mm-hmm.
The moment drives got to the point where the manufacturing capability started to exceed the defined limits, like if I, what is it? A disk could have 255 tracks, was it?
Yeah, that was like
something
one of the
like that.
upper limits. Yeah. Yeah.
Well, when somebody figured out that, well, we know how to put 510 tracks on the hard drive now, but the software won't take it. So what we're going to do is we're going to have it claim that it has twice as
Right.
many
Right.
sectors
It's an
per track.
emulation mode. Right. Right.
Once they started making those, once they started lying, we lost all ability to perform that optimization.
Sure. Sure.
Yeah.
Another thing happened with those drives. Remember initially a track would have like 17 sectors. So you take a
Yes.
track and divide it into 17. That's what you had. Closer to the center, they were very tight sectors. Way out on the
Yes.
edge of the disk, they were very wide sectors. So they figured out how to do variable sectors. Well,
Mhm.
you just lost your ability to do any kind of geometry. It had to be
Yep.
a virtual geometry at that point.
Yep.
You know, I mean, they might have 3,500 sectors on the outer track and
So
17 on the inner track.
LBA is just an acknowledgement of the truth.
Yeah. Yeah.
It's all a lie.
Yeah. You can't fake physics, right?
No, you just.
Yeah.
And
I got a question.
yeah,
With the advent of solid state hard drives, rotating hard drives going to be becoming obsolete?
Pretty much. Yeah.
yeah, eventually. We have a huge install base of massive
Sure.
storage arrays built on spinning drives. And it's going to be a while until they all go away.
Sure. But any mobile device is going to be SSD,
Yep.
you know, because
And
of the power savings, because it uses much less power than a spinning drive and it's more reliable. So yeah, it's going away.
it is, but when is obsolete really happening? In 1999, I did computer consulting at a printing company. And they had an ancient system that was connected to the network via 2X, which is the predecessor to coax. It had an in cable and an out cable, as everybody runs for their Google. Twin axle. But
the olden days.
and you know, they had a twin X to AUI adapter and an AUI to Cat5 adapter. I'm not sure if I was crying tears of joy or horror, but one of those. So as long as it's used, there will be people making it.
I think too, with the solid state versus spinning rust hard drives, one of the things is data recovery on those things. SSD, once they launch themselves, they are pretty much read only, and that's it. And sometimes things can get very, very wonky in that regard. Whereas with the spinning rust, at least there's a bit of a fighting chance, I think, to get stuff off of it if necessary. But I don't know. I mean, the thing have gotten so convergent that, you know, before it was okay, yeah, you could say that the spinning Rust, you could throw a whole bunch of drives into a drive bay or something like that and call it a day. Whereas nowadays, yeah, you have stuff like NVMe and all this other stuff that you can toss in there and get a similar capacity without spending a whole heck of a lot of money. But you've got companies like Backblaze that are still using spinning Rust and still testing spinning Rust. Part of that is because spinning Rust at rest is perfectly fine and crimelant as opposed to SSDs at rest.
Yep. So,
yeah.
will they
Go
become
eat.
They'll become fringe at
Yeah.
best.
Exactly. And so we bring to a close Michael Lucas's talk. Thank you so much, Michael, for all of this. I'm
My
going to turn
pleasure.
off the live stream